In the shadowed, high-security bays of Hyderabad's research center Emarat, a project whispered about for years is finally stepping out of the classified world and closer to the launch pad. This is Project VEDA, the Vehicle for Defense Application, a system designed not for scientific exploration, but for wartime survival. After years of silent development, exclusive information suggests that DRDO is now targeting the first quarter of 2026 for the maiden developmental launch. What once existed only as rumors inside defense corridors has now become a fully assembled, full-scale rocket preparing for its first ascent into orbit. VEDA represents India's answer to one of the most serious vulnerabilities of modern warfare, the possibility of losing space-based surveillance and communication systems during a conflict. As China expands its anti-satellite missile arsenal and tests robotic grappler satellites capable of disabling enemy spacecraft, India has realized that a rapid, self-contained satellite-launching rocket is not a luxury, but a necessity. Designed as a three-stage, all-solid propellant missile system, VEDA borrows its core from the cage for submarine-launched ballistic missile. By leveraging propulsion units already tested for nuclear deterrence, DRDO has avoided years of foundational research and created a rocket that can be stored for long durations without maintenance, transported discreetly in standardized canisters, and readied for launch in under 72 hours. The performance envelope of VEDA is exceptional, especially for a rocket intended for purely military operations. Capable of placing up to 2,000 kilograms into low Earth orbit or nearly 1,000 kilograms into sun-synchronous orbit, VEDA can deploy ASATs equivalent to a Cartosat imaging satellite with ease. It can also launch clusters of lightweight synthetic aperture radar satellites, which are able to provide day-night, all-weather surveillance even through cloud cover. With global militaries shifting toward responsive space operations, where satellites are launched on demand during emergencies, VEDA positions India alongside the United States' Tactically Responsive Space (TACRS) program and China's Kuaizhou Quick Response System. What makes VEDA so critical is not just its launch capability, but the independence it provides to India's armed forces. During a shooting war, the Indian military cannot afford to wait for ISRO to clear civilian launch schedules or shuffle priorities. If Chinese ASAT weapons disable Indian satellites or if long-range Pakistani weapons strike key communication nodes, VEDA becomes the emergency lifeline. Strategic Forces Command can immediately mobilize a VEDA launcher, attach a pre-assembled satellite, and restore vital space capabilities within a day. This ensures India's surveillance grid, missile early warning network, and battlefield communication links remain functional even during the most intense phases of conflict. For its maiden 2026 test mission, DRDO has set up a temporary launch pad along the Andhra Pradesh-Odisha coastline. The rocket will carry an 1,800-kilogram dummy mass to a 600-kilometer polar orbit. This mission will validate the rocket staging sequence, thrust curves, thermal management, and the accuracy of an advanced inertial navigation system specifically hardened against cyber interference, GPS jamming, and spoofing attempts. These features reflect modern threats, where space warfare now includes not only missiles but also electronic attacks targeting a rocket's guidance. Once operational, VEDA missions will not rely on fixed coastal sites at all. Instead, the entire launch complex, including climate-controlled stages, mobile erector launchers, command vehicles, and data link stations, has been built for dispersed deployment across inland locations. Forested areas, abandoned industrial belts, and even semi-urban camouflage techniques will make it extremely difficult for foreign reconnaissance satellites to track or preempt a launch. Internally, VEDA's engineering lineage ties back very clearly to the K for SLBM program. The first two stages retain the composite motor casings and flex nozzle thrust vectoring identical to the submarine missile. DRDO's experience with underwater cold launches has proven the reliability of these motors under extreme stress conditions. The third stage, however, is an entirely new design, wider, more efficient, and filled with almost double the propellant of the original K for post-boost module. This enlarged stage provides the precise orbital injection burn necessary for placing satellites into polar or high-inclination orbits with much greater accuracy than older Indian tactical rockets. One of the most remarkable achievements of VEDA is the time it saves. Since K-4 technologies have already undergone decades of testing, DRDO has bypassed years of propulsion trials, vibration tests, and structural analysis. The same motors designed to launch nuclear warheads from submerged Arahant-class submarines will now carry India's wartime surveillance systems back into space. This dual-use adaptation mirrors strategies employed by both the United States and Russia during the Cold War, where ballistic missile technologies were repurposed into rapid launch vehicles to maintain space superiority. Behind the scenes, the secrecy surrounding Project VEDA is unprecedented even by Indian defense standards. Budget allocations are disguised under vague titles such as Strategic Propulsion Studies. Test sites are booked under pseudonyms, and only a handful of officers within Strategic Forces Command and DRDO's Missile Directorate have full access to project data. Key industry partners, including Godrej Aerospace, Walchandnagar Industries, and several composite manufacturers in Hyderabad, are operating under lifetime non-disclosure agreements. Even within the military, information is compartmentalized, reflecting how deeply classified and strategically important VEDA has become. As space rapidly evolves into the next theater of warfare, India is preparing for a future where conflict may involve disabling satellites, jamming communication networks, and targeting orbital assets. In such a scenario, VEDA is not just a rocket, it is a strategic shield. It ensures that India's ability to see, communicate, and coordinate from space can never be permanently taken away, no matter how intense the conflict becomes.